Hello, this is Team 5 of Junior Design, starring James DeLeon, Sam Sefe-Mero, Brenda Rodriguez, and Michael Abdel Malak. And what we are designing is the pressure sensitive seat. So what we have here is a seat cushion, and attached to the seat cushion are load cells with adhesion to the seat. At each corner, there is a specific load cell that will capture the weight of anybody or anything that applies pressure down onto the seat as such. And it is all connected to an Arduino, and to make sure that there is a proper strain on the load cells, there is a block of wood at the bottom of this seat so that there is a firm strain on the load cells. Now, with the load cells, it will read a very analog value, so it will convert the analog value to a digital floating number in order to be read by the Arduino. And the Arduino is connected to the app via Bluetooth, and Sam here will talk about the Bluetooth software.
So the Bluetooth application of the Arduino required a bit of embedded programming. We had to utilize the HX711 libraries to use these actual load cells. And more or less what it does is it will add up all of the load cells together, whatever measurement they get, one for each corner of the seat, and combine them and then send them to the Arduino, which will not only send to this serial monitor, but will also be sent to my phone. So both can be used as a means of All right, now we can go into the timer. We will say about 20 seconds it will go for. Now we will go back. We can go ahead and connect to the Bluetooth device. It is now connected. It has an amount of weight on it. And now if we check the amount of time that has elapsed, now the alarm goes off. And we'll go after a certain amount of time to make sure you are off the seat.
So as you can see, the 3D printed models that produce the strain on the load cells were printed by James and Michael. And as you could see, the load cells themselves lie outside of the seat cushion itself, which is not a problem in terms of any weight being applied to the seat. But for cosmetic purposes, we would have liked to ingrain the load cell and the 3D printed strain model inside of the cushion in order to make it more modular and easier to carry around and portable.
Some of the things that we were unable to implement as well was to create a weight distribution graph. In order to do that, we would have had to have provided a lot more graphical methods, and the amount of delay between the Arduino and MIT app using Bluetooth is just not feasible for creating a real-time graph. Realistically, the best we could do is displaying the numbers. We also thought about making different cells read different weights, which is possible. However, one of the biggest issues is making sure that each of the load cells are working in accordance, and that tended to be a general issue whenever testing out the device. The HC05 just had a general amount of trouble sending multiple values at one time if they were all working in real time with one another. It may have something to do with clock speed, but I believe if we had a bit more time, we could have implemented them.